So we have two rather large chapters to get through today. We've got this first chapter on changing the user interface dynamically, and I believe it's something like 29 slides. Yes, it says 29 slides for that. And then we've got the web component chapter, which is our last chapter today, and I believe it's about the same. It's about 29 slides as well. So we'll definitely need a break today. We'll get through this user interface chapter, which is the long one. We'll take a break, and then we have a short chapter on start menus. It's very short, though. It's only, I think, 12 or 13 slides. And then, depending on how you're feeling, we'll jump right into that last chapter on web components and try to get that finished in a reasonable amount of time. But it wouldn't surprise me today. We've been getting through in about 2 hours. Today, it's more likely to take 2.5 or even 3 hours today, since we have two big chapters. So changing the user interface dynamically. When we finish this module, you should be able to figure out or find the Genero methods to reference an object, change an attribute of a form item, load user interface components like toolbars, top menus, action default files using a special built-in class method. So those are all the resource files we've been talking about as the week's gone on. Hide, enable, or disable fields in the user interface, load XML, refresh the interface, identify the client, and actually much, much more. This is just a short summary of some of the things we'll learn about in this chapter. So first, a short discussion of these built-in classes that have to do with the user interface. We have several built-in classes, which means they're part of the runtime system. You don't have to do anything special to use methods in these built-in classes like import the class or do any kind of linking. It's all already built in. So we have this ui.Window class. You can tell just from the name of these classes what user interface component they have methods to act upon. So ui.Window, of course, is going to have methods that you can use to manage and manipulate windows. We have a ui.Form class that, of course, is intended to manipulate form components, form elements, and items. We have a class just for working with combo boxes, and we'll visit with that class today. And you even have a lab where you'll work with the ui.ComboBox class to load a combo box dynamically using some of these special built-in class methods. Then we have the ui.Interface class, which has methods in it that operate on components at the interface level, say versus the form level, right? So it's work at a high level. Things like loading these resource files and making the resources in them available to the entire interface. That's the type of thing that you do with ui.Interface methods. And then we have some methods that we've looked at already yesterday to act on the interactive instructions, the dialogues we've been talking about. This ui.Dialog class has all kinds of methods that we can use to manipulate these interactive dialogues, like our display array, input, construct, and so on. And we've visited some of those methods already. And then we have this Om package that has this DomNode class, and that's used to manipulate the user interface at a lower level, right? We're getting all the way down to this DOM tree structure, the abstract user interface itself that we've been talking about. So very low level types of methods there to manipulate the abstract user interface tree, the DOM tree in memory. So starting with this ui.Interface built-in class, here's some of the different methods you can use to work with these resource files that we've been working with the whole week. Things like our presentation styles file, our action defaults file, toolbar files, all these different resource files where we can create essentially XML resources that we can load into the abstract user interface tree. These are very simple. They're all just looking at them, they're all class methods. So literally all you have to do is use the call command, call ui.Interface load toolbar, and then the name of the toolbar. And notice for the resource files, you don't have to include the extension. It's smart enough to know that a toolbar has a 4TM, or a presentation styles file has a .4st, for example. So it's smart enough to figure that out. Notice also that you don't have to include the path for these. They're just literally using the simple name of the resource file for these different methods. And that's because it's smart enough to go out and use environment variables to be able to find the directory structures that have been configured for either the dbPath environment variable, which is an older method, but it's still supported for backwards compatibility. Nowadays we use FGL resource path for our environment variable typically to specify the list of directories that it needs to search for things like these resource files. So we don't have to put the full path in, it'll search automatically using the FGL resource path environment variable. Here's some additional ui.Interface methods. I don't think we've talked about any of these previously, so these may all be new for us. This first one, this ui.Interface.refresh, is only necessary when you're not currently working with an interactive dialog, an interactive instruction. If we're in the middle of a dialog where we're working with the end user, all of that synchronization between the front end and the runtime system is handled automatically. Our runtime system takes care of keeping the abstract user interface tree that it currently has in sync with what's on the front end for the user. The only time we really need this refresh method is if we're doing something like some batch processing, and let's say we're doing something that takes a long time, the user's sitting there wondering what's happening, we can use a display statement, perhaps to display a message to the user, and then we need to use this ui.Interface refresh method to go ahead and refresh the screen so that he sees that message. So it's not something you would use very often. Typically just when you're working with something in kind of a batch mode where we're not working with interactive dialogues for the moment. The next one, this ui.getFrontEndName, is to identify the type of client that the user is working with. So ui.getFrontEndName, the string that it returns will just be simply, for example, GDC, Genero Desktop Client, or GWC for Genero Web Client. That's the string that you would get back from using that command. So it helps you identify what type of client is in use. And then finally, the last one we see here, this ui.getText, just returns the title of the program. So you can see there's a lot of other methods. There's a ui.setText, for example, that you can use to set the title of the program. Just an introduction to some of the types of methods we have with ui.Interface. So here's a look at this ui.Window built-in class. You can see here there's a couple of class methods. Let me grab my highlighter. We have this forName class method and a getCurrent class method. Those are both methods that we can use to get a reference to a window so that we can use object methods, for example, to manipulate the window. The forName actually is looking for a window specifying the name of the window. So you're looking for a particular window object with that forName method. The second method is probably more common because it just says, I want the current window, whatever the name of that window is. So two different class methods, both of them intended to get a reference to a window. One just the current window, the other one a specific window by name. And then we have these object methods, lots of object methods for the window class, the ui.window class. We've got this find_node object method. We'll actually see some of this later when we're talking about some of these other built-in classes that we can use to work at a very low level with our DOM tree, our DOM document in memory. But we have this method with the ui.window class to find a specific node in the DOM document. So here we've got this get node option to return the node for the current window. So that's the specific node for the window that we're looking for there. Here's the set text and get text we just saw on the previous page that we can use to get or set the title of the window. And then we've got an option here to create an empty form. So you can see a few of these methods are not used that much anymore. Some of these methods were used in bygone days to go out and create a form from scratch or manipulate nodes in the DOM document. Nowadays we have a lot of special new class methods that we can use to do the same thing, but do it much more easily. So here's an example of using some of the ui.window methods. Up here at the top, we've got an example of getting a reference to the current window with this ui.window.getCurrent. And first here we've defined a variable w that's a ui.window object, and then we're assigning a reference to the current window object to this variable w. So w now has a reference to the current window. And we're doing the same thing here in the second example, except this time we're using this forName method to look for the specific window W1. So we only want a reference to the W1 window in this case. And then we're going to assign this reference to this variable W. And then here we're changing the current window title. So here we're getting a reference to the current window with this class method getCurrent. Now that we have a reference here with this variable W, we can use this setText method and change the title to Illinois customers, it looks like. Here's some methods from the ui.Form class. Now I know we've talked about the ui.Form class some yesterday or maybe even the first day, and one of the things that is a little surprising about it is that just now we looked at the ui.window class and we saw two different methods that we could use to get a reference to a window. But notice that we don't have any class methods to get a reference to a form. So there's no create method here, no create class method here that we can use to create a new form, and there's no method that we can use to get a reference to the current form that's already been created. So that makes this class unique compared to, say, the ui.window class, which has two different methods to be able to get that reference. So we use other methods. We've seen one like ui.Dialog method. We'll see that again that we can use to get a reference to a form. And we've got the window method that we can use to get a reference to the form. Once we have a reference to a form, we've got some object methods here that we can use to manipulate elements and items in the form. So we can make sure, for example, that a field is visible. That's not used very often. The only thing I can think of offhand that you would maybe use that for is something that's typically hidden. You could use this to force it to be shown in the interface. For example, a folder page. If you're using folder pages, perhaps there's a different folder page in view, and you can force a different folder page to come in view with this ensure field visible. You pick a field, for example, that's in the folder page that you want to be shown. Same thing here with this ensure element visible, except it's an element versus a form field. Something like a label, for example. Here's a find node and a get node object method that you can use to find a specific node. And get node here returns, if I remember right, remember the documentation is very handy for these. I'm just going through here picking on the ones that I think I remember exactly what they do. But this get node I believe, returns the node in the DOM tree for the form. So it gives you access to that node. And here we've got some ui.Form methods to load resource files. A few minutes ago, we saw the ui.Interface class methods that we could use to load Action Defaults resource file, toolbar resource files, top menu resource files. So now here we're seeing an object method to do the same thing at the form level. So if you remember the priority that we've talked about previously, when I load something at the interface level, if I use that ui.Interface method to, let's say, load a toolbar or load a top menu, then I come back and load a top menu with this with this form object method. The form object method is going to have a higher priority. So anytime I load something at the form level with this ui.Form class, it's going to win over anything I've already loaded at the interface level. So keep that in mind. If you have a toolbar that you want to use in general for all your forms, you can use the ui.Interface method that we saw earlier. And that loads that toolbar or top menu, whatever it happens to be, for all the forms that are created. But then if you have a special top menu for a specific form, you can use this method and it will override the global setting, the ui.Interface default. And then down here at the bottom, there's just a bunch of methods: setElementHidden, setElementText, setElementImage, that you can use to manipulate elements and items on the form. So elements would be something like a label or any of the widgets, for example, combo box and so on. And then the fields like set field hidden, set field style, and so on, those are for form fields that we use to view and manipulate data. So here's an example of referencing a form object. So we're using UI Dialog.getForm to get a reference to the form. So just a minute ago we saw that we didn't have any ui.Form class methods that we could use to get a reference to a form so that we could use those object methods. But here we can see two different ways to do it. So the first one here is with the ui.Dialog class, and we can use a dialog method. In this case they're using that dialog keyword because it's inside of an interactive dialog block at this point. So we can use the keyword dialog, that predefined variable, to reference the current dialog. And then the getForm method to get a reference to the form, the current form. So that's one method we can use, one of the dialog class methods. And then there's an additional method we can use, this ui.Window.getForm. And this again can be used once you have a reference to the current window, which we have here with this variable w. Then we can use the ui.Window.getCurrent to get a reference to the current form for that window. Whoops, sorry. That's getting a reference to the current window, and then right here is our ui.Window.getForm method to get a reference to the current form for that window. Whoops, I got ahead of myself. And here's some of the object methods you can use with ui.Form to manipulate elements. So setElementHidden, it doesn't just gray out an element. Previously, if you've been working on the labs and you've made it this far, what we were doing earlier and talking about yesterday was going in and just disabling elements in the form, kind of deactivating them, so to speak. So we could actually go in here and kind of gray out elements in the form, like actions, for example. We had options yesterday where we looked at actually graying out actions so that the user could no longer select those actions. Well, now what we're looking at is not just disabling elements such as labels or actions or whatever you might be working with, but actually hiding them altogether. So instead of them being grayed out so that the user can't interact with them, you would actually have more of an effect like we see on the right. It actually hides the element. In this case, it's a group, right? So we have a group defined to hold a couple of interactive elements like buttons, and if we hide the group, it also hides any of the components in that group or elements in that group. So you get the effect you see on the right. It's as though it was never there. So we can hide and show elements with this setElementHidden. And it works as a toggle. So here, just to walk through this example, we've defined a couple of variables, one for our window object and one for our form object to hold our references. We've opened a window, W1, with a form. And here we're getting a reference to the current window with this class method, ui.Window.getCurrent, and assigning that reference to our variable W. And then we're getting a reference to the current form in that window with this ui.Window.getForm method that we learned about previously. So now we have a reference to the form. We can use this form object method, setElementHidden, to hide a specific element by name. So here we're using this group 1, the name of that group, and the 1 is a toggle that says yes, we want to hide it. Now later, if we choose to show that group again, we could just use the same command but just use a 0. So some additional examples, changing an attribute of a form item. Here we've got the setElementText method, setElementImage, setElementStyle. Here we're looking at form fields, so we're using the setFieldStyle, setFieldHidden, and again setElementHidden. So just to walk through part of that example, you can see they're all very similar. We'll start up here at the top. Here we've defined our variables already up there at the top. We just can't see that in this example. So we just assume we've defined variables. And here we're getting a reference to the current window and assigning it to a variable W. Here we're using this ui.Window method to get a reference to the current form in that window. And now we can use these form methods to manipulate objects on the form. So our form reference, our variable for that is F1, has a reference to our current form. So now we can use the object method setElementText to set the text for label 1. That's a label on the form, and that's the actual name of the label. So if you clicked on that label in Form Designer and went to the properties over on the right-hand side, you would see that the name of that label is LB1. Right, so that's the property. And then we're setting the label text to new text. So setting the label text to new text for the label label1 with that method. And a similar thing here, setElementImage, we're going to specify an image to be used for our quit to exit.png. And same thing here, label 1, we want the element style for our LB1 object in the form to be the MyStyle style. Now that's handy, right? This is a way that we can apply a presentation style on the fly programmatically. So we've been looking at all these different ways that we could apply a style. We've talked about the attributes clause, for example, with a window. We can use the attributes clause to apply a style to a window, and that's programmatically as well. But later, if I choose to change the style again for an object, I can use this method. Now this is just for components at the form level. Set element style for a specific label, in this case, to a style. And here's the same thing, except it's for a form field. Category.catDescription is a form field on the form that's handling data, and I can change the style in this case to integrated search. hide a field. So if I want to hide a form field, in this case it looks like state name. Again, it's just a toggle is what most of these methods are using. So one says hide it, it's true, and if I choose to show it later, I can set it to 0 so that it's false and it won't hide it anymore. Here's setting a label element, LB2, hiding it by setting it to 1, and then I could show it again by running the same command with a 0. And this again is talking about loading components at the form level, loading these resource files that we've been talking about for a specific form versus using an interface level method, ui.Interface method. So these will have a higher priority. So this is what you would use if you typically use a ui.Interface method to load presentation styles or toolbars, top menus, and then you have a form that's different from the typical. And then you can use this method to load whatever resource file you're working with at that form level for that specific form. So it will be different and have a different look and feel then than your other forms. So here we're getting a reference to the window with this ui.window.getCurrent, then getting a reference to the current form for that window, and now we can use load action defaults to load this my defaults action defaults file just for this specific form. Same thing here with the toolbar. So we're loading a specific toolbar for this specific form, and top menu down at the bottom. So those are form level methods versus interface level methods, and they have a higher priority. Now, one of the ways that you can easily use methods to load things for all forms or for specific forms is to specify initializer. The set default initializer is for all forms. So ui.Form.setDefaultInitializer, and this init that you see over here on the right here, this parameter, is the name of an initializer function. And you always specify that in lowercase. So your functions might have camel case names, but we require the initialization function here to be in lowercase. So here we've called this default initializer, and what this does, notice where we have this up in the main program block as the program is initiated or launched, and what this will do is define this initializer function for all forms. So from now on, while that application's running, anytime a form is opened, a form is created, it's going to automatically get a reference to this new form that's opened and call this initializer function, sending a reference to that newly opened form as a parameter. Right, it's going to pass it by reference to this function. So now here's our function init. We've passed in a reference to the current form that's just been opened, and now we can do things like load top menus or load action default files. So this is a common way to kind of initialize a form to give it the same look and feel as all your other forms. So using a kind of a default or global initialization function for that. So we've looked at the ui.Dialog class in a previous chapter, so that's why this slide is labeled as a review. But since we're talking about all these special classes and methods that we use to work with the user interface in this chapter, it's a good place to quickly review. So here we've got this keyword dialog, set field active. We can use that to allow the user to interact with the field is what we're doing here. But actually setting it to 0 in this case is disabling the field. I should have looked at the end there. So this one's set to 0, so this is actually disabling a field. Down here we're enabling and disabling actions. In this case the move 1 is a defined action, and setting that to 1 enables it. Setting it to 0 disables it. And likewise, set action hidden, we can use the 1 to hide the action and the 0 to show the action. So a quick review there. In this case we're using this special ui.Dialog predefined reference to the current dialog. Keyword. So here's the ui.ComboBox class. I don't think we've talked about this previously, so maybe all of the methods here will be new methods for you. So previously, when we've talked about populating a combo box, we've talked about doing it right there in the form using the combo box widget and properties for that widgets. There's an items property to populate the combo box. So that's one way to do it, but it's a very static method. So if the items in a combo box are dependent on, let's say, database values, perhaps it's a list of supported states or a list of countries that you do business with, and those lists of countries or states or cities, whatever it might be, is prone to change, you would not want to use that method because you would have to go in and edit your form every time you added a new country to your business or added a new city that you do business with. So using methods from this class is a much more dynamic way of populating a combo box. So this would be the preferred method if you're getting information for a combo box from the database. So the ui.ComboBox has couple of class methods. This first one is to get a reference to a specific combo box. So that's a class method to get that reference. And then we also have a class method to set a default initializer, just like we saw with forms a few minutes ago, that we could use to populate items for all combo boxes. I'm not sure how often you would use a default initializer for a combo box, but you have that option. And then we have object methods down here. Once we have a reference to a combo box, we have object methods that we can use to clear out any previous information in the combo box with this clear object method, or just clear something. If, for example, we think we've made a mistake, we can programmatically do that. And in here we've got the object method to add an item to the combo box. And if you remember, combo box items, there's two elements or two items in a combo box. We've got the name of the combo box item, and then we've got the text value, which is just what the user sees. Now when the user selects something from a combo box, what gets returned is the name. So the name gets returned, the text is the user-friendly property of the combo box to help the user pick something from the list. So then we've got this get column name. Again, I don't know how often you might use some of these different object methods, but we've got an object method to do everything with combo box. Get information from the combo box or populate it with the add item. So later in your lab, you'll actually be working with this ui.ComboBox class and using these methods to populate a combo box. I've got an example of that. I was going to see if I could find it quickly here to give you a break from all of these commands. Here we go. Let me pull this over. So here we've got an application called Accounts that's using the default initializer method to load the combo box or initialize the combo box. So here's way up here in the main program block, we're calling this set default initializer method, and anytime now a combo box is created in a form, it's going to call this default initializer function, init combo box, and pass a reference to this newly created combo box to this function. Now the function itself is in this module, accounts maint, and I don't know if I've shown you this, but I was going to try to show you more about moving around in the Genero Studio interface. So one of the things that's handy over here is the code structure view. So when you're working with a big module, and this one's not that big, but it's fairly substantial, the easiest way to find a function that you're looking for is just to go over here and look in the code structure view. So if I go over in the code structure view, it's real easy for me to find this init combo box function. All I have to do is click on that, and it puts me right in the location of that function here on line 346. So just a quick shortcut, how do you find a function in a large module? Use the code structure view and just look for it there in the structure. So here's this initializer function init combo box, and of course we mentioned that the way these default initializers work is when the element is created, in this case the combo box, it is automatically sent by reference or passed by reference to this initializer function. So here we've got a reference to the combo box that's just been created, and it's passed into this function. And right here we have a variable CB defined as type ui.ComboBox object. So now we have a reference to the combo box with this CB variable. So here we've got a couple of other variables defined, C-code description, because it looks like we're going to load this combo box with database data from the country table. So to retrieve data from the table, we're going to define a cursor. This is the same type of cursor that you've worked with before. If you've taken the Genero Language Basics class, you're familiar with reading data from the database with a cursor. So this is not new. Declare the cursor, and here's our select statement. We're looking for the code and the code description from the country table. First, we're initializing our combo box by clearing out the elements with this cb.clear. And now we're going to use a for each loop with our cursor to read from the database all of our table data, C-code and C-code description from the database, and load that into our combo box with this add item method. So we're just in a for each loop, reading through the data in the database table and using that data to populate the combo box with this cb.addItem method. And that's it. That is all there is to it. If you want to see what that looks like, make sure I get the right program, okay? It's pretty simple. To see that in action, to get the combo box active, I'm going to do a query and then a modify. Notice it's not active here when we're just in read-only mode or in read mode. But if we do a modify, now all of a sudden our combo box is active, and we can see the effect of our populating our combo box here. Now if we look at the form, I know you've seen combo boxes before, but if we look at our form, it's going to be different than what we've worked with previously. Here in our form, here's our combo box widget on the country field. So here it is in the form structure view, combo box, and in here in the properties, previously we configured our combo box items right here with the items property. Remember, we went in and we populated our items this way, adding items and text manually. Very static. So if our database changes and we have new countries that are supported, it won't be reflected right now in our combo box next time it's built. So this method is a static method. It's not going to be updated when the database changes. But if I use the initializer function, then of course I can use a cursor, read fresh data from the database when the combo box is built, and that way we make sure that our combo box is up to date. While we're in here, let me just show you one more thing. Notice this initializer here And this is a property for the combo box. So what we're using in the example I showed you is a default initializer that would be working for all combo boxes built in a form. If you want to use a specific initializer function for a combo box, you can use this initializer property. So you'd specify the name of your initializer function here, and this combo box, the country combo box that we have selected, would use this initializer function instead of the global default that we set with that set default initializer function. Okay, so a break from the slides for a minute. ui.ComboBox. So we just saw this. Just going to see if we need to review any of that. I guess it doesn't hurt to go through it quickly. We just saw this, so very quickly we have to define a variable for our object reference. So here's a variable CB that we're going to use to hold this reference to a ui.ComboBox object that's just been built. And then we have to get a reference to the object either by using this forName method that we saw, or we can just use an initializer function which will automatically get a reference to the combo box object when it's built. And then it will invoke that initializer function and pass that reference to the function. That's the method that we just looked at here using the set default initializer. And then you can fill the combo box either with static items. You can specify them just like this, call cb.addItem and hard code them in there, which again would be a very static method, very similar to defining them in the form file like we were looking at a few minutes ago. Or you can use a cursor set. Here we're looking at the initializer function in the form. This is what I was just showing you a second ago. So I can also define an initializer function at the form level instead of using that set default initializer method that we saw a minute ago. So this will be unique for this specific combo box. You can also do that with the form, the .per file version of the form. You just use the attributes component, you just use the initializer attribute for that and name your function there. So we just saw this too. I showed it to you in the actual code example. Right there in the main program block is typically where you'll set your default initializers for forms or combo boxes. So ui.ComboBox.set default initializer, and then you name the function that you're going to use for your combo box initialization routine. And down here is another example of populating a combo box differently than what we saw. This is using a static method. So we're just hard coding these values to populate our combo box. So again, not very dynamic. If the list of cities changes and we keep all that information in a database, doing it this way, we'll actually have to change the code to add a city next time our combo box is built. Much better to use a cursor and read that from a database table if that's a possibility. And there's the example we just looked at in the code. So loading a combo box dynamically, define a cursor, use a for each statement to read data from the database tables, and then use your object methods, your combo box object methods, to add those items to the combo box. Here's another package I was talking about briefly that provides low-level access to our abstract user interface tree, our DOM document. So these classes for the Om package are not used that much anymore. They are still used. I don't want to make you think that they're obsolete, but they're not used as often. We have other methods, like methods we saw with the Dialog class, the Form class, the Window class, the ui.Interface class. We have newer methods that make that a lot easier to manage than getting down to this level. So here we've got our DOM document class that provides XML document handling. We have the DomNode class that gets you down lower to the XML node level. We have a node list class that holds a list of DOM nodes that have been retrieved with some sort of selection. And then we have some methods that can be used to work with XML, read, write, XML. So some examples. Here we've got D, a variable D defined as an om.DOM document object, and R defined as an om.DomNode object. And here we're creating a new DOM document with this class method, this DOM document class method create, and that will create a new DOM document called my document. And then this D, now that we have a reference to the DOM document, this get document element returns essentially the root node of that DOM document back to this variable R. Now has a reference to the root node of that DOM document. So that gives us access to a brand new DOM document. So if we wanted to create a form, for example, from scratch, these would be methods to get us started with that. To select nodes in a DOM document, you can use this DOM node. A couple of options here that they're showing you to be able to select a specific DOM node. There's a select by tag name, and that's the tag name that you would see. Let me show you quickly what that's referring to. Run an application here. If I do a control right click, the tag name here that it's referring to is over here, like Hbox, grid, window, form. Those are the tags that you'd be using, not the tag that you see over here. So essentially the type of item that we have. So that's the select by tag name. If you're using that, you can quickly find out what tag name you should use by using that debug tree, control right click, and identifying the tag names. There's also a select by path that's a more difficult method. We'll see some examples of that here in just a minute using XPath search patterns. You can also select a DOM node with ui.Window.find_node. There's a simpler way to select a DOM node. So here's an example using the select by tag name. Here we've got some defined variables. dnode is om.DomNode object. dlist is an om.NodeList object to hold a list of nodes returned from searching with a pattern. And then we have a string and an integer variable defined. So here first off we're getting selecting the node for the form, select by tag name form. So here we're getting a reference to the node represented by the form. So we have access now to the form. And then once we have access to that node for the form, then we can use additional methods to manipulate items on the form. So here we're going through and getting a list of all the nodes on the form, or the number of nodes in a form, and then doing a for loop to work through the nodes in that form, assigning each form to a variable, and then changing the text for the item that's been identified there as just the text for the form title in this case. In any case, it's getting a reference here to the text for the form item and then changing the form text to uppercase with this to uppercase method. Now that's a method of the base.stringBuffer class. So we're using a different class to be able to manipulate that string. Here we're talking about looking for nodes in the tree using an expression to identify patterns. So we're actually looking for nodes based on patterns. So these are all W3C standards. We don't use all of them, but we have certain ones that we support, like the slash, which represents an absolute path to a required element. We recognize the double slash for all elements in a document that fulfill your selection criteria. And then we also support the asterisk that selects all the elements located by a path. And then we've got this option, attribute equal value, to select elements that have attributes that match a specific value. So if you know what you're looking for, you can use that method, and it will be very specific about picking nodes from the tree. So here's an example of this select by class. So here's our defined variables. We have an om.DomNode variable defined, an om.NodeList variable defined, and then an integer. And here we're using our pattern, DNode.selectByPath, and then we're looking for all instances of this window, and this is the name attribute for the window, is gift cert. So we're looking for windows that have this matching name. And we're supporting more than one window, and all of the nodes that match that criteria are added to this om.NodeList, D-list. So now we have a list of nodes that match that criteria. And now that we have that list of nodes, we can act on it. Here we're using a for loop here to go through the list of nodes that were returned, and then change the style for those windows to a pop-up style. And here's an example of ui.window.findNode. Here we're getting a reference to the current window, and you can see that this is a simpler method to find a node. So here we're assigning this label. We're looking for nodes with the name label, specifically the customer ID label, and then we're assigning a reference to that label to this pnode variable, or a reference to the node for that label to this pnode variable. And then we can change the color using an object method, pnode.setAttribute, and the attribute we're changing is the color attribute for that node, and we're changing it to red. And here's an example of finding a Vbox on a form. So if you remember from discussions of forms, creating forms, we have various types of containers for a form. And all of our elements and form fields that we have in a form can't just be free-floating out there in a form. They have to be confined within a container. And a parent container for a form is either a vertical box or a horizontal box. So we have V boxes and we have H boxes. So in this particular example, they're looking for a vertical box parent container in a form. Perhaps they're going to find the vertical box and then create some additional form items inside that parent container. Or perhaps they're going to look for form items contained within that parent container. Not sure yet. So here we're defining a couple of variables. We've got a couple of DomNode, om.DomNode variables defined, dForm and dBox. And here we're looking for, we've passed in a reference to this node representing the form. So here, now that we have the reference, we're looking for the first child node in that form. And here we've got a while loop, and we're looking and checking that child node to see if the tag name is Vbox. And if it's Vbox, then we're going to act on that node in some fashion. And if it's Vbox, we're just assigning right now a reference to D_box and getting the next reference. So we're just going through this list of nodes looking for a Vbox on the form using a while loop. Here we're adding a node to a form, so this might be something that you would do after getting a reference to this Vbox. So now that you've got a reference to the node representing the Vbox, you could do something like add a node to a form. Remember, you can't just add something and have it floating around freely. You would have to have it within some sort of a container. So here we've got a function called addLabel, and we're passing in possibly this reference to this Vbox node, DomNode. And then down here, we're creating a child for the node we have passed in. So let's say it's the Vbox. So we have a vertical box parent node, and now we're creating a child for that parent node. And it looks like it's going to be a label. And then here we're setting the attributes for that child node. So these are attributes that pertain to labels. Positions, the width, the text is going to be hello, and the color is going to be magenta. So essentially the last few slides we've gone out and found the DOM node associated with the form. We've located the Vbox DOM node on the form, and now we're adding a node to the form, in this case a label, to the Vbox. Alright, so that took exactly an hour to get through. That's not too bad for 29 slides, I think. So the next chapter is only 12 slides long. This one won't take nearly so long as the last chapter, and it's on start menus. So some program environments have an overall program with a main menu that's used to start other programs. So that's really what a start menu is. It's just a program that is used to start other programs. To use a start menu, there's 3 or 4 steps that you have to go through. It has a resource file, very similar to the resource files we've already talked about. It's an XML resource file, and you have to load that resource file. So we now know the ui.Interface methods to do a lot of these things. So we can launch our start menu, launch our programs from a start menu program, and we'll also learn how to group program windows into a parent container. You actually have to configure the parent container, and then the programs that you want to be launched from the parent have to be configured as well. They have to know that they're children and which parent container they belong to. So there's configuration on both sides, the parent program and who is the parent container and the child containers. So a start menu defines a tree of commands that start programs. Each program can only have one start menu that it's associated with, that it belongs to. Typically, you create a dedicated BDL program, and that program has the commands in it to create or load a start menu. Typically, we load the start menu from a resource file. You've learned how to do that this week. And then the program needs to perform some sort of interactive instruction. It could be display array. Typically, it's a menu, but it doesn't make any difference. The purpose of the interactive instruction is so that the parent program is sitting there basically waiting in an interactive instruction so that it's active, and users then can launch programs. So it's just kind of in a habitually waiting state, I guess you could say. So we'll see an example of that here in just a minute. And then you need to configure MDI, which is short for Multiple Document Interface, to group your programs launched from the start menu into a parent container. So to do that configuration, you actually do have different settings for the parent container and the child container. So more on this multiple document interface. By default, whenever we kick off a window, you've noticed that the windows are just displayed independently. They go where they want to, you can move them around, and that's called SDI, or Single Document Interface. But you can configure your user interface to group your program windows into a parent container, and that's called MDI, or Multiple Document Interface. We call it WCI at Genero, Window Container Interface. So just a slightly different term, but it's essentially the same thing. So this is what it looks like. I have that exact program here that I believe that I used to create a screenshot just like that. So let me just fire it off. And you can get an idea of what the start program looks like. Now in this case, we've got the option here to display our start menu as a tree view. So it's got this tree view over here with these nodes that can be expanded or collapsed. But you also have other options that we'll see so that you can have a different look and feel to your start menu other than a tree view. So here is our different styles. What we just looked at was the tree style, and you can see that all we've done here to configure this tree style is just created a style in our styles file, just like you've used for all your other styles that you've worked with this week. But the special style we're looking at here, the attribute, it's for Windows, the window objects, and its start menu position is the attribute we're looking at. And right here the value can be tree, our pop tree, our menu. Those are our three types of start menus that you can configure. Right now, if we looked at our style file, which we will in just a minute, we can see that the value equals tree right now. We'll take a look at that too in just a minute. So pop tree, of course, looks like this. You have your window that just pops up. It looks very similar to a regular window that you run, but it is confined within that parent container. It just moves around freely inside of that container. And then over here we've got this menu style. You can see over here that it just creates the menu options just like a top menu at the top. So a slightly different look and feel. You just pick the one that you like the best. So implementing a start menu with WCI, that's our term for it, is create a start menu resource file, and you would do that just the same way that we've learned to create all these different resource files. You just bring up Genero Studio, go to File, New, and then in our Genero category over here, we've got all of our resource file options down here at the bottom. So we're looking for a start menu resource file right here. And you can see that if you pop that open, it gives you the XML format that you need, and then you can just substitute your own commands. So it's XML. We've got this idea of a start menu element here with a start menu group. So we have groups like day 1 programs, day 2 programs would be a separate group in our example, day 3 programs. And then the command itself is the actual program that you want to launch from that group, or the list of programs that you want to launch from that group. So each start menu command is able to launch a single application. Notice you don't have to have the extension. Can't think of the right word for that. You don't have to use the extension with that, the runnable extension, the .42R. You can just leave it at this, and it's smart enough to figure that out. Whoops, sorry about that. That's the text. Here it is down here at the bottom. FGL run account array .42R. This is just the text that the user sees. And to configure the start menu style, we just talked about how inside the styles file, you've got this concept of a start menu position attribute, and then you specify whether or not you want it to be, for example, menu or tree. Those are the two most popular styles of start menus. Something else I want to point out is this window.main up here. Window.main is one of the predefined window styles. If you create a new styles file and look at that new styles file, there's a bunch of kind of pre-configured styles that you can keep or you could delete if you wanted to. And one of those is window.main. So there's actually two window.mains. There's a window.main and a window.main2, and you can just pick the one that you like the best. You can also modify these just like you can a style that you created yourself. But that will automatically, this window.main, the style attributes for that are automatically picked up by your start menu. It's smart enough to know that window.main is the style that I'm looking for. And then you need to configure the WCI parent container. Well, to configure it, one step is to write your dedicated BDL program that's going to contain your other program windows. Again, it needs to have an interactive instruction in there so that it's kind of in a waiting condition or in an interactive condition perpetually to make it available as a start menu program. But then you also need to configure your child programs as well. We've got settings that we're going to configure inside this dedicated BDL program for the parent that specify, for example, its name. And the child programs have to be configured to be child programs and also to be a child of that parent. So they have to specify the parent's name as well. So there's an example of the start menu resource file, very similar to the one I have set up for you to look at. So here's our start menu and end for our start menu. So there's our start menu element. Here's our start menu group, the text for that group, and then the individual commands that launch the programs. There's also a start menu separator, I believe, as well. This would be a good time for us to go out and look at the documentation. I don't know if you're the same way, but I never remember all the details and all the different commands or options or attributes that we have available. So usually what I'll do is go check the documentation. So let's take a quick peek at that, just to make sure that I don't tell you something that's not right, for one thing. So I'm just going to look up Start Menu. And just by clicking, I know that start menus are part of the window. So I'm looking for window properties or window styles. So here's accelerator keys that I can add to my styles for start menus. I've got start menu position that we just talked about that have our different types of styles for start menus, the tree style or the menu style, pop tree. I can define shortcuts. The default, by the way, to open a start menu is Control-Shift-F12, which is not extremely intuitive, but you can change that default here with the start menu shortcut that you can define. You can also define a size for your start menu. And then right down here is our different options for our parent container. Here we have this tabbed container if we want tabs. So the child windows, when they're launched, can be shown as tabs, which looks very nice and tidy. I'll show you that here in just a few minutes. And then we've got our close method for our tabbed containers. So whether or not they can use the close button is kind of what that's applying to, and which close buttons are available for them. So there's where you can find information about your start menus. Start menus essentially are just a style of window, so you can look in your window style attributes for that. All right, so start menus. What I'm looking for now are the start menu attributes for the actual start menu itself, the resource file that we were just talking about. So just to pop in there and look at that, we've got all of our syntax to create our start menus. So we've got our Start Menu group. We've got our Start Menu commands. I was just looking to see here, Start Menu group, Start Menu command node, just to see what's here. Text. There we go. I was wanting to make sure I had mentioned that you could use a separator with start menus, but I didn't see it right away. But right down here in Table 4, we have our attributes of the start menu separator. So you do have the ability to use a separator with start menus to separate your items. More of a decorative attribute for that. But anyway, here's your documentation that specifies all the different attributes that you can include in your start menu resource file. You can even have a group that's disabled, which means it's just grayed out and can't be selected when the user starts it up. You can hide it altogether so that it's not visible if you like. So you might do something like this based on, for example, running some code to see who your users are. Maybe you have groups of users that have different privileges, and based on the user that's running the start menu, you might choose to hide or disable different groups in the application so that they do or don't have access to that group of applications. Okay, and then right down here we've looked at these ui.Interface methods for loading all kinds of resource files. So here's just one more to load a top menu. ui.Interface.load, did I say top menu? Start menu, to load a start menu. ui.Interface.load start menu, and then you just give it the name of your start menu resource file. Here's some of the start menu attributes. We just looked through those, so I won't go through all of these one after the other. But you saw it's just an XML file a few minutes ago that you can edit just like you can your styles file or your action defaults resource file. These are just your attributes that are available to you. So there's our text for the start menu to be displayed as a title. You've got your groups. Like in my case, I was using group day 1, day 2 programs, day 1 programs, and so on. So I had groups of applications based on the day of class. So you have all kinds of things you can, other attributes you can associate with that group. I could have an image, like an icon that's displayed for the group if I wanted to. I also have the ability to disable the group or hide the group if I like. This start menu command, of course, is the node in the start menu that actually launches the program, so that's mandatory. And there's the text that the user sees, usually the name of the application that you want them to see. So here we're looking at the start menu window styles. This one is just showing you that applications that are started in a start menu, you had that option to render it in folder tabs. So we actually saw the style for that a few minutes ago described, but here's a screenshot of a style file that has that configured. So here's our window.main, which is one of our pre-configured default window styles that comes with a new styles file. And if you look at it, you can just add attributes like this and specify the type of start menu. They call that the start menu position attribute. This one's a menu where we have what looks like a top menu up here at the top. And then we've got this tabbed container attribute set to yes, and that's why these child programs are launched, and once they're launched, they're tabbed in a tabbed formation across the top up there. A nice tidy way to do it. Has a nice appearance, I think. So we have various ui.Interface instructions that we use to configure the parent container. Some of these are mandatory and some of them are optional. So again, you'd want to look at your documentation for specifics on these, but I can tell you that this first one is mandatory. You have to tell the parent that it is the parent. So the set name SM_parent is mandatory. This is now our parent container. And then here we're saying the set type is container. So these two lines, these first two lines, specify that this is a container, a WCI container, and that it is the parent container. So those are mandatory. And then load start menu, of course, is the way we load our start menu. So may not be necessarily mandatory, but you'll want to load your start menu. The size is not mandatory. You can just let it determine its own size if you like, but I wanted to put an example in there of something that wasn't mandatory. And we said that the parent program needs to have some sort of interactive instruction in it. So we're using a menu statement here. Here's our menu and our end menu. We've got an on action close up here to allow our user to exit the start menu application. But one thing we're doing is making sure that if he does that, if he triggers this close action by clicking on the red X in the corner, if there's any child applications currently launched, we don't want the parent to be closed. That'll actually generate a runtime error. So instead of generating a runtime error by letting them close the parent window, we're going to check here with a little code ui.Interface.getChildCount. So it's referring to child programs there for the parent, the WCI container program, and if there's more than 0, if there's any launched, then it doesn't actually close. Instead we're saying you have to exit the child programs first, and we just put them right back in that menu statement. Otherwise, if there are not any child programs running, then we go ahead and exit out of the menu. We let him go ahead and close the program. Now the child container also has to have some configuration done as well. It doesn't know that it's a child container unless you tell the application that it's a child container. So right here in the main program block of the child program, we need two different methods from the ui.Interface class. We've got the set container here to tell it who the parent container is. And if you were to look back at the previous page or two, you would see that when we created the parent container, we named it SM_parent. So this child container has to refer to his parent so that it knows it's linked essentially to that parent container this way. So this is where he specifies his parent container by name, and then right here the set type, he's not a parent, he is a child container. So those two lines are both mandatory for child programs that are going to be launched inside the parent. So there's all of the slides for that. So let's just take a look at all of these pieces and parts quickly here. Let's see. So I showed you a minute ago, I ran the start menu program, so you could see we currently are using the style of using a tree type start menu. So our different groups here are displayed in a tree fashion, a tree format, and then we can launch our programs here by double clicking on the program. And notice we're also using that tabbed format, so these child programs here are rendered here as in tabs. So I think I have two of them configured. So there I've got two different tabs now. I've got this display array program is launched and it's tabbed, and then I've got the categories application as well running. And I can just pop between those here inside my parent container, inside my container program. I can change that style. Now, notice if I click the red X here, let's see what happens. Uh-oh, apparently I don't have my parent container. Okay. Looking for my message here. There we go. I'm clicking on the wrong red X here. Okay, so right up here at the top, of course, is my parent container red X. I was just hitting the wrong one. If you click on the X, the close button associated with the parent container, it's complaining. It says I can't actually close the start menu parent program because I've got some child programs that are currently running. This display array is still running here. So if I quit out of the child program, now I should be able to close out of my parent program, and it let me do it. So just to kind of demonstrate that piece of code there that we saw a few minutes ago. So here if we look at our styles file, this default.4st file we've been using for our styles file, here's our window.main style that we use for our start menus, and there's our start menu position, which determines the type of look and feel for our start menu, which right now is kind of a tree view type style. So if I wanted to change that, I have other options. One of them was a menu option. I can just change that here in my style file. And right here again is my tabbed container attribute, which is why my child programs end up launched and tabbed up there in that nice tabbed format at the top, rendered in tabs. So now I should be ready to run it again. Let's see what happens. And now this time, instead of the tree view that we had over here on the left-hand side, we're using this rather like a top menu type start menu. Up here at the top, I have my day 1, day 2, day 3 groups, and in those, of course, I can launch my individual programs from those days. Still using my tabbed format, so I'm still getting that nice tabbed rendering. But just the start menu itself now is rendered in a different style. Very simple to work with and configure. Did the same thing again. All right, so I need to close out of these before I can quit out of the parent program. So the Start Menus chapter is very short. It's only about 12 pages long. So I'm going to go ahead and pop open the Web Components chapter. And let's go ahead and do this chapter, and then we can call it, actually we can call it a day and we can call it a class. This is the last day of our user interface class today. We've saved the Web Components for last. Web Components are a fairly new feature of Genero BDL. It's the ability to integrate these third-party widgets, they're graphical widgets that we can integrate into our forms and our BDL applications. And it gives us access to a big range of nice graphical features like charts and graphs. We can access Google Web Components and do all kinds of things with them that we could never do before. Web Components have been around for a couple of versions. I believe they are actually introduced in Genero 2.30, I believe. I don't have that right in front of me, but just be aware they've been around for a while, but they're still fairly new features, so they're undergoing enhancements every version. So 3.0 is not any different. We still have Web Components. If you've been utilizing Web Components that you've integrated in previous versions, those will still work, but now you have some easier methods to work with Web Components than were available to you in the 2.50, for example. And I'll try to point those out as we get to them. So by the end of this module, you'll be able to describe the benefits of integrating Web Components into your application and be able to implement them into your application. So we have two different ways to implement Web Components now. We have the GIC API type Web Components, and that's pretty hard to say. So what I usually do is I just call it GICAPI for short. So that's the acronym that I'll use. I'll just say GICAPI, and you'll know I'm talking about this GIC API type Web Components. And now in more current versions, we have URL-based Web Components as well. Now URL-based Web Components were first available with 2.50 if you had Genero Mobile, but they weren't available for Genero Enterprise or Genero that's not Genero Mobile until 3.0. So now they're available in our 3.0 Genero Enterprise product. So we have two different ways to implement Web Components. We have this older method of using these GICAPI style implementations of web components, and then we now have URL-based web components. And we'll talk about the difference between those here in just a minute. So to integrate a web component, you need to implement your GICAPI or URL-based web component. You need to define a web component field. It's a new type of widget that we have for our form files. So you're going to integrate the web component into your form by using this special new type of widget for the form file. And then you use your web component in a dialog of a program just like you normally would. You can use it with an input statement, for example. So we'll see some examples of that. So first, a better explanation of what web components really are. So web components are widget templates that you can reuse easily and reliably. So you can either write the widget yourself, write the web component yourself based on HTML with JavaScript, or you can use somebody else's web component that they've already implemented. And that's the whole idea about it being reusable easily and reliably, is you don't have to write these yourselves. You can just, so to speak, borrow them from somebody that has already created them. Reusable templates, reusable widgets. So there's a lot of third-party components, these web components out there that you can use. Some of them, though, are licensed. So something to kind of watch out for when you're working with web components and you're looking for new, nice graphical features that you can integrate into your Genero applications. Be careful of using any that might be licensed, because then there's, of course, a cost associated with that. But there's some nice ones out there. There's some chart and graph widgets. Some of those I know are licensed. I've seen some of those. Calendar widgets, drawing widgets, and so on. So I mentioned earlier there's two different ways to implement web components now with version 3 of Genero. You can use the older method, which is using what I'm calling a GICAPI type web component, GIC API type web component. But to use the GICAPI type web components, you have to be familiar with JavaScript, or at least be familiar enough to be able to put all your files that are needed together and understand what's happening. So that requires some JavaScript coding. And you have to write a form field plugin to get or set the value of this web component form field. And that's how these web components are really integrated into your form, is through this web component form field. So you have to be able to get the value of the web component if it changes, and then of course you're displaying it to this special web component field. We'll see more on that too here in just a few minutes. And it relies on finding some required files to execute. For example, the JavaScript, the HTML file that has the actual scripting in it, it has to be able to locate that file. If you have any image files associated with the web component. The one I'm going to use for demonstration does have an image file, so I have to be able to locate those files, and we'll talk more about how to locate them or configure Genero to be able to locate these web files here more towards the middle of the chapter. Then we also have these newer URL type web components. So the URL type web components are actually hosted on a third-party server. So you don't have as many requirements to be able to work with them. They're easier to work with. You don't have to, for example, do any JavaScript yourself. You don't have to write any type of form fill plugin to get or set values for a third-party web component that's integrated as a URL type web component. So it's much easier to work with one of these than it is with the older style GICAPI type web components. In version 3, our engineers came out with some new front-end functions that, for one thing, make it easier to work with some of the older GICAPI style web components. Previously, we relied on having this plugin that you had to write, essentially a special object that allowed it to set properties and fire triggers and all these types of things, but we had to do a lot of communication to be able to set properties and change values and get data. And now we've got special front calls that we can use, so we can call a JavaScript function in the web component using a front call method. So we've got this front call method. Let me just point these out. ui.Interface.frontCall, and then we're specifying here a special web component module. That's the module that contains the function. And then the function itself here is called call. And so this call function actually allows you to call a function inside of a web component. This AUI name is the name of the web component in the abstract user interface. Typically it's the same name that you would have for the special form field, the web component form field. And then function name that you're wanting to call inside that web component, and then some optional parameters. If that function requires parameters being passed in, you have that ability here. And then of course you also have the ability to return information from the function, return a result. So we're going to first focus on this first style of being able to implement a web component using this GICAPI method. So to integrate a GICAPI style web component, first thing that you would need to do is either write or identify a web component that you want to use and get the source code, which will consist of an HTML file, any other additional JavaScript that's required by that web component, CSS files, anything like that that's required for that web component. You need to gather the source code for that. Then you need to implement the interface script on the front end. So you do have to, like for deployment purposes, you have to deploy these interface scripts on the front end where they'll be used. Then you have to also make sure you define the location where the front end can find these GICAPI interface files. It has to be able to locate them when the web component is used or integrated into the program. You have to define a web component field, the special new type of widget in your form specification file, and it's got this special widget type. It's actually a web component item type, a new item type just for web components. And then finally, you can just use the web component in the dialog of the program, like an input statement, for example. So here it's referring to the web component interface script. So here it's talking about this interface script has a GICAPI global object that has to be implemented. And the purpose of this GICAPI global object is to transfer data or requests from the web component to the BDL program and vice versa. If there's an event or a change in the BDL program that needs to be sent to the web component, then we're using this GICAPI global object for that. It has special functions for that. So here it's talking about this GICAPI object that we have in our HTML for our GICAPI integrated web components. And we've got a couple of different object methods for communicating from the GICAPI web component to transfer information to the BDL program. So the first one here is set data. Grab my highlighter. So this set data object method is used by the web component to send information in plain text to the BDL program. For example, in the example I'm going to show you here in a few minutes, it would just be information about the state that's been selected on a map. So it's sending information to the BDL program, and the format it uses is just plain text. So that's a very commonly used method. And then we've also got the set focus method that just generates a focus change request from the DVM, the runtime system. The user clicks on something, it generates the set focus request. And then we've got an action method that can be used to trigger an action. Just the same actions that we're familiar with. We can define an action and specify that this GI object method triggers that action, which in turn triggers some code handling, right, some on-action clause code in our BDL program. So let's take a look here at that part and figure out how we're working with that in our example. Let me pull up the example and we'll just look at it from scratch. Get rid of this. So I've got a GI style web component called WCMap here. That's this application node at the bottom. And you notice that here I've got a lot of the required files for that web component. It does have several. There's an image file. That's what it looks like, just a map of the United States that this web component requires. It has a 4GL program, of course, associated with it. It has an HTML file that has our JavaScript with our GI object defined. Here's the methods that we just talked about, the setData method. Here's the action method that can be used to trigger an action in our BDL code. And some additional initialization methods here. And we'll talk about this on property here in just a few seconds. So let's focus on this part right here up at the top, the setData. So what this is doing is when a user clicks on this map, then essentially it triggers an action. Let me show you the bottom first before we go too far. So here's the bottom, and this essentially is the coordinates for that map. So all of these coordinates identify a location on the map that's associated, of course, with a state. So when the user clicks on an area of the map, with this onClick method here that's attached to this map element, it actually kicks off this function or calls this function called execAction and passes a state to it, like North Dakota. So that's what happens when a user clicks on an area of the map. It identifies where he's clicking by these coordinates, and it kicks off this function, execAction, and it passes in a state when it runs that method, the execAction method. So up here, here's our execAction function, our method, and then here's the function that it's working with. It gets passed in the state, and in here it's going through and using this setData special object method to pass the name of that state back to the BDL program, the DVM, right, our runtime system. So essentially we have a map of the US. The user clicks on a state, which triggers that execAction method, calls this execAction function, and then sets the state and uses this setData to pass that state information back to the Genero runtime system. So now we know the name of the state back in the Genero program. And at the same time, it also triggers this action state, fires the action. So if we look in our BDL program now, here's our BDL program. And in the BDL program, we just have a main program block. We're opening a window with our form that has our web component. It's going to be our web component map. And then we have this input by name. This is our interactive instruction that we're using to interact with the web component. And then when that trigger is fired, that on-action state is fired, then we're going to display that state that we get back with that setData method to the state name form field. So the two pieces are working together. The BDL application is working with the web component to allow users to select a state. The web component sends the state information back to the DVM and triggers the action state. When the action state is triggered in the BDL program, then it goes ahead and displays the state information to the form. So it all kind of works together to create a nice interface where the user can pop around and pick states and see information about those states. Now, in addition to just displaying the state information, it also runs a function, calls a function, initData, sends that state to the function. It's right down here. And you can see that this initData function is just a big case statement that takes the state and finds the capital and the largest city for that state with a case statement. And then it passes that information back to the calling function. So it comes back up here to this dialog, and then we're displaying the capital and the largest city to the corresponding form fields in the form. So that's what is all happening together here between our GICAPI object with our special methods here, this setData method and this action method to be able to fire a trigger, and then our BDL code that actually executes some code for the action handler for state to actually display the state information. So let's see what that looks like. So here we're running our application, and we'll look at the part that actually causes this state to be displayed to our special new form field widget here in just a moment too. We'll look at the form. But for right now, let's just worry about this part where we're exchanging information between the web component and the BDL program. So if I click on a state, I'll click on Oklahoma. When I clicked on that state, of course it was certain coordinates that I clicked on there, and in our HTML it was able to identify that. I pop back over here that I clicked on Oklahoma based on those coordinates, wherever it is. There it is, right down here. So when I clicked on that state, it also kicked off this exec action method or function and passed Oklahoma to it. So if we go up here, so it ran this setData, it passed Oklahoma then back to the BDL application or our DVM at that point, and then it also triggered this action state. And when it triggered the action state, if you remember, our BDL application then went through the big case statement to find out what the capital and the largest city was for Oklahoma, and displayed those to these form fields, capital and largest city up here at the top. So it's kind of an entertaining web component. We can click around and see what the largest city and the capital is of any state in the U.S. So now there's another part to that. Let me go back to the slide for just a minute. And we have some communication that has to go back between the BDL program back to the web component. So what we just saw was somebody clicking on the web component in a certain area on the map, and the web component identified the state, and it used a special method to send that back to the BDL program. This time we're going the other way. This time we've got our BDL program that's going to be getting some information and sending that to the web component. So we use different methods for that. So some of the methods we have for communication this other way, from the BDL program to the web component, we have onFocus, which just gets called when the program sets focus in or out. So from the web component, we had a method to ask for the focus. From going this direction, we have a method we use when the program sets the focus, so that the component sees that the focus is set. The main one, I think, is this onData, and this is what's called when a form field value changes. So when a form field value changes that's associated with the web component, when the web component form field changes, then the runtime system is going to send information back to the web component using this onData method. So that's how it sends information back. Now, if you look, though, here we're looking at JSON, right? We've got this JavaScript built-in eval method that we can use to evaluate a JSON string here. So going this direction, the information is passed to the web component in JSON format. And so here it's evaluating that JSON string. In this case, to change the contents of the title, set the title. So let's see what that looks like so you kind of understand what you're looking at. Should have just left it running, shouldn't I? Grab that. So right here we've got a change title option. When I click that, I just get a prompt. We'll see that here in the BDL code in just a minute. And I can specify what I want to change the title to. I'll change it to my title. So I changed that through the BDL application, but the web component had to get that information and evaluate it to change the values, the contents of the web component. And it did that, right? This is the web component area form field for my form, and it has this title in it. So for that to happen, it looks very simple and straightforward, but for that to happen, we have these two things working together. So we had our code. If we look at our code here, I guess I closed that. Find that. 1 second. Here we go. On action ch title, call change title. So the user clicks the button in the corner that said change title, and that called this function change title. Go way down here to find it. All it did was prompt us to enter the title. We saw that a minute ago. Prompt change title to, and then I typed in a response, my title. And here it's just saying, by the way, this is using some very low-level abstract user interface tree modification. This is the same thing we were looking at in the previous chapter. Not the previous chapter, but the first one today, to learn how to use some of these special low-level commands to manipulate the DOM nodes. So here we're using the easy method of getting a reference to the current window and getting a reference to the node for the title. So when, this is the ui.Window.FindNode method that we saw earlier. That's an easy way to get access to a specific node. And here we're looking for a node with for the property. And we're passing a string to it, which is the string for the title. Call property.setAttribute value, which is our value that we're sending to it, and we're calling it title, which is the string my title. So we've got that in the BDL code, and then that sends information to the web component. The DVM sends information to the web component, and it handles it here with this onProperty method to evaluate this JSON string that has that title, and then it uses that JSON string to populate this area of the web component, the div for the web component. So there's the back and forth communication using those different types of GICAPI object methods. So now we're talking about defining the form file. You have to define the form file with the special web component type, web component item type. It's a brand new component type, or relatively new, starting when web components started. So let's take a look at our web component type here. We're just using a simple text base per form file for this example instead of form designer forms, easy to read. So here we've got an attributes section here that specifies a web component, and the form field is called selected state. That's this form field right up here, selected state. It's form only. Typically web components aren't associated with databases, so they're defined as form only typically, .SelectedState. So there's defining our special web component widget or web component form type. Here's some attributes, stretch equal both so that the user can resize the window, component type equal map. Now that's mandatory for a GICAPI style web component. That component type equal to map is actually mapping this form or this form field to the HTML file that has the JavaScript. So that part is mandatory for the GICAPI web components to enable it to find the JavaScript associated with the web component, find the files associated. And it has one property, which is the title that we looked at how to change in the previous section there. So there's an example of this special form item type just for web components for being able to integrate that web component into the form field. So here they're saying this component type then has to match the name of the interface script, so they're mapped together. So make web components available to Form Designer. Now we didn't do this with our example I showed you. We just used a simple per file for our form. It's actually a simpler way to do things when you're working with web components or GICAPI type web components. But if you want to use Form Designer, there's an additional step required where you have to create a special configuration file called a WC settings file. It's another one of these XML files that we're getting very familiar with, and you just define all the properties for the web component in this WC settings file. And remember that the name of the WC settings file is important. It's what kind of associates that file with the web component. And then right here you have to specify, this is setting it in Genero configurations for Genero Studios, where it's going to be able to find those WC settings files that define all the properties for the web component. So in this case we've got it buried way under training material, etc., etc., just to show you how you set that. There's a special environment variable. Pop that up here so you can see it maybe more clearly. There it is. Could not see it to save my life. There we go, web components. For some reason, with it being a W, I'm expecting to see it at the bottom, so it was avoiding me. But anyway, I don't have that configured here. So I've got, here's this GST WC dir. The reason I don't have it configured is because I'm not using a WC settings file. I just use the per file instead. But if you choose to use a Form Designer file, then you'll need to configure a WC settings file with the properties for that web component defined, and then you have to specify here with this environment variable for Genero Studio purposes how it can find the WC files, the WC setting files for these web components. So right here is where I would put the directory path for those WC settings files. So that's where you do that. And of course this one is not used because I'm using a simple text-based file, this style of a file for my form file. So here we're showing adding a web component widget. Once you've created this WC settings file, then you're able to integrate the web component into your form. And the way you do that is just by creating a web component widget. Now with Form Designer, you have to use the widget option for that, or convert a form field to a web component widget that's already there. And then right over here then, this will give you a combo box. It'll look in the directory that you specified with that environment variable that identified the WC settings directory, and all the WC settings files that it finds there will be displayed in a combo box. So this time we just picked this chart WC settings file from the combo box, and that then allows me to embed or integrate this chart web component into this form. So you can see there's an extra step there to be able to use Form Designer, and for our purposes today, I just opted instead to use a simple perform file. And all I have to do here is just specify in text that it's a web component and the name of the web component. I don't have to do all that setup so that I can pick it from a combo box. So here it's talking about using the web component in programs with a simple dialog. So here we're using an input by name, and we're saying input by name selected state. So essentially we're starting off like this, just putting us in an input on the BDL side, waiting for the user to click on an area of the map, which then will start this whole process of triggering object methods there for the GI web component, which in turn eventually it will identify the state, send it back to the DVM, and then we've got this triggered state. The action state is triggered as well. Remember that the GI web component is able to raise an action, so it triggers the state action, and here in our input statement we're going to display that state to the proper form field. So all of this is just tied together back and forth between the web component to the BDL program. So here's our selected state that we're trying to input. Now we can see that it's a form field essentially in our form where we've integrated this web component. This is referring to the idea of being able to find image resources. There's different types of image resources used by web components. We've got static image resources that are just part of the GI web component implementation. For example, the map that we just saw. And then there's also image resources that are private, or variable type image resources displayed by the program at runtime. So two different types of image resources. This is talking about how to configure Genero to be able to locate those resources. There's different ways depending on whether it's static or variable type image resources. So here we're talking about the static image resources. You can reference them with an absolute URL this way, and that would work. You can deploy them as part of the GI web component assets and reference them then with relative URLs this way. So there's different ways to manage it, and then we're going to use environment variables there to build a path to those. Using those partial paths, it'll build a complete path from that using environment variables. And then the HTML content of your web component then can reference them this way. And again, that's kind of a relative path, but it will go ahead and use environment variables to build a complete path from that. So here it's referring to private or variable image resources. So these are resources that are displayed by the program at runtime versus being a part of the web component configuration. And these you can reference with an absolute URL. You can provide by using a special ui.Interface method, file name to URI, if you're running an application on a server behind the gas. And that essentially builds a full path, a URL with the full path, using directories that have been identified with FGL image path environment variable. So that's a method then to build a path that's usable with the gas. And then we've got this FGL image path environment variable that you can use by itself when you're using a direct connection like we're using today with GDC. So there's an example of what that looks like, this file name to URI, special ui.Interface method. So here we've got our input by name on change, and here we're using this file name to URI to build a usable URL from the path that we have defined and from FGL image path environment variable, right? The directory specified by that. That gives it a starting point, a root directory to start searching for this image. For your gas configuration for web components, there's a special element here, web component directory, and then you can specify the path, and that's how it knows where to find the web components. So this is the special as.xcf configuration file we use to configure the application server, applications used by the application server. So this is our gas configuration file. So this entry is used by GWC and GDC if you're connected using the application server to find the web component directory. So there's just an example, finding it here, choosing the application directory / web component, and if we looked out there, this would be where it's expecting to find all these web components files. For direct connections, we can just use the FGL image path environment variable, and just to show you that, that's what I've done here for this one. If I look at advanced properties for that web component example I've been showing you, and I look at environment variables, I've just got my FGL image path environment variable set to point to my project directory, and then in my project directory I just have a directory called GICAPI files, and that's where I have all the pieces and parts for this web component, the HTML file, the image file that it needs. So there it's just talking about how it's searched. These web component files are searched in this order: FGL image path, web components, component type.html, and so on. Now you'll find URL-based web components easier to understand and easier to work with. They're fairly straightforward most of the time. So to integrate a URL-based web component, you need to identify the URL of the hosted web component. So these are always hosted on a third-party server. We don't have to do all of this configuration and writing the GICAPI object and HTML that we have to write for the GICAPI type web components. So we just identify the URL of the hosted web component we want to use, create the form specification file, defining a web component field, but this time we don't use the component type attribute like we do with a GICAPI style web component. Remember that the purpose of that component type attribute is to point to the script, right? The actual interface script that has the GICAPI object in it. Well, we don't use that with URL-based web components, so we just leave the component type property empty. So in the program, set the URL of the hosted web component in the form field value, and then use the web component in the dialog of the program. You can use it just like you would a regular edit field in your dialogs. And we saw a similar thing with the input statement for a GICAPI web component. So that's the same as a GICAPI web component, that last step. So here we're defining a form for a URL-based web component. This time we're using Form Designer. And here we've got our web component widget named MyMap here. So we just right-clicked on, let's say maybe it was an edit field, and we changed the widget. Remember there's a convert option there, and we changed it to be a web component style widget. And then down here we have our properties for web components, and we're just leaving that empty, this web component type property. Usually for a GICAPI web component, it's going to be mapping that to the interface file. But here we don't need that because there is no interface file to map to. So here we're setting the URL in the form field value. So here we're defining some variables to do that, and then we're just displaying the URL. And of course we're displaying that URL to our web component field. And here they're saying just use the variable in an input with the unbuffered option. And here's an example we'll be looking at here in a minute. So we're defining a record in this case. We have a constant working with Google Maps. CGMaps equal http maps.google.com. Then we have a record defined rec with a MyMap member, location, and value. 3 members all defined as string variables. Then we're opening our form, displaying the form. We're setting our record location to Paris, and then we're building a URL from that, maps.google.com, and then we're appending the Paris information to that and going to send that to Google Maps. All right, so that's a URL for referencing a location in Google Maps. So let's see what that looks like so you can see how it works. That's this node right here, wc_gmaps. Just run it first. We'll go ahead and stop everything else. And here's what it looks like. So essentially we hard-coded in a location of Paris to get us started here. So we're just looking at a Google map of Paris. Now I can change, let me go ahead and change one and we'll look at the code that does this here in a second. Let's change it to Plano, Texas. That's where I'm at today. And we have a button edit in our form right over here. I'm going to click that button edit to trigger an action. And notice I have this message, URL has changed. So it's giving me a time here that the URL has changed. And now all of a sudden my location has changed and I'm looking at Plano, Texas instead of Paris, France. So let's see what happens here in our code for that. So here is our application, webcomp.4gl. Here's our record that's been defined that we looked at a moment ago with MyMap, location, and value defined as strings as members of that record. Here's our constant for Google Maps, https maps.google.com. Opening our form, setting our initial location here to Paris. So this is our record location equal Paris. And now we're calling a function called setMyMap. And if we go down to setMyMap, it says if the user interface is get front end name as GDC, then use this simple concatenated value for the URL. If it's not GDC, it requires an additional key out there to work with the web browser. So that's what we're doing here. So we're setting that value and coming back, and then we're entering an input by name. This is our dialog that we talked about using the web component in a dialog of our program. And if we trigger this on action setLoc, that's our button edit that we saw a few minutes ago, it's again going to call this function setMyMap and update the value with this new value that's been input by the user. On change, it's able with this on change value to detect changes to the web component form field. So on a change it says, okay, I need to update that value and give the user a message the URL has changed so that they know that something has happened. Little additional information for the user there. Just to show you that you can use the on change to detect changes to the web component field. Just looking to see if there's anything exciting that I'm not showing you. I think so. That looks good. Okay, so the URLs are just pretty simple to work with, the URL type web components. So if you look at the form for that, notice there's not any additional files because it's all handled on the web server that we're talking to. So I don't have an image file or an HTML file with JavaScript. I just have a simple BDL form file and a BDL program. and setting a URL to send. So my profile is very simple. I've got my web component form field here defined. It's a web component widget, but notice I don't have that component type attribute set because it's not a GICAPI web component. So here it's referring to the on change, the idea of being able to detect changes. So you can see that with an on change, and then of course that fired our trigger when the URL changed, and that updated the value for our URL. You can also use the front end call. We talked about this earlier once already. This special front call class, or a front call method, UI interface class method that you could use to talk directly to a web component and call a function in a web component, which is much easier than the older method that we used with these GICAPI objects that we looked at earlier. So you can just directly call a function in a web component and run it on demand with this instead of having to use various properties and ways to work around that. To debug web components, there's maybe several pieces and parts involved. You can use the Genero Studio graphical debugger for the BDL program part of your web component integration, but that doesn't do you any good for any JavaScript part. So if you're working with GICAPI web components, or Genero debugger, it doesn't understand JavaScript, so it won't help you with that part. So that's when you'll need to use some sort of third-party or browser tools to debug the interface script. So it may require more than one tool for debugging. So we can debug somewhat with the GDC, the Genero Desktop Client, which is what we're using today for class purposes. To be able to do that, you have to start up the desktop client in debug mode, which is this -D option when you start up the client. And you can see that here. So once you start it up in debug mode, then you have the ability to bring up the desktop client interface. Let me just show you that. I think that's easier to follow if I show it to you. So here we're talking about, here we've got GDC Use Display Client. And if I click on that, I can see my GDC client configuration here, and I can see that I've started it up with a -D right there. So that's what we were looking at a minute ago. So again, to get there, I clicked on the wrench icon, which you can get to that wrench icon up here at the top in the toolbar. Tools, Genero configurations is another place, or the wrench down here in the bottom right-hand corner. That's the one I clicked on. All three places will get you the same information though. So then I went in here in my configuration management interface, and then I'm using the Genero desktop client here, so I clicked on this edit icon at the end, and that tells me my Genero client configuration here. I've got all these options I can configure. And again, here's the -D option, starting it up with the debugger option. So I'm going to double click on my desktop client icon here to bring it up, and way over here in the corner is my debug section, and here in debug I've got this option for a console. So I'm going to use that to see what's going on when I run this web component. Now before I launch that, what I should have done is check all my messages. Let me kill that for a second. So right here, notice I'm got web container selected, and then down here I've got verbose level set all the way high. You can of course adjust that however you like. I've got it all the way up. And then this checkbox, enable web component debugger. So I want to have that selected when I'm looking at web components. And then I'm going to click this show option right here to bring up that console. Now notice initially it's empty until I actually run the web component. So I'll run this map web component down here. So there it is. I have to find my console. I lost my console. There we go. It disappeared under a lot of other things. So this is what it looks like. This is our debugger information from the debug console that we have with the GDC. So it's all color-coded here. The pink here is our communication back and forth between the web component and well, it's our communication to and from the web component. So you can see here where it's calling all this. This is a GI web component. So you're seeing here when it's using some of these functions or calling some of these functions. See status information and that type of thing. Whoops. It's getting hard to see. Let me minimize that again. Pull this up. So here you can see where it's used the onData function. Because I clicked on an area of the map, you'll see that again here. See onData Kansas. Remember that sets the value that then gets sent to our runtime system so that it has the information from the web component. So you can see all of that. So it's a fairly good debugging tool. You can see all these different methods that we've programmed into our GI web component JavaScript. So that's one debugging tool that you can use to kind of monitor and see exactly what's being called and what's happening when you're working with the web components. It's color-coded, I mentioned, so the runtime to the GDC is the black. You saw a lot of black text there. And in the program and web component interaction, which is what we're really focusing on, is all this pink. Now if you see any blue in there, which I didn't think to look, but if you see any dark blue, that's the GDC information from it. And that looks like that's it. That wasn't okay, so you have one more lab to do. And kill all this and get it out of the way here. So here's our lab for the last day of class, Modules 6, 7, and 8. First thing, just like yesterday, the first thing you're going to do is organize your project structure to add a new group for the Lab 3 exercises. And then you're going to create a new application node called Hide Group. So you're going to first copy some applications that you worked on yesterday, or an application that you worked on yesterday, the DAMD-MRS4GL source file. So you're going to copy that and save it into this new application node and name it HideGroupMRS.4GL. And you're going to do the same thing with the form. You're going to copy it in and change the name to HideGroupMRS4FD. So now you've got this new group, this new group, day 3, and a new application, Hide Group. So now instead of just disabling your actions like you did for the previous lab, we're going to use some of these new methods that we learned to manipulate form objects to actually hide the group. So it kind of walks you through all the steps you need to do to actually hide the group that contains those actions instead of just disabling them, graying them out. Then in exercise 3, you're going to define a default initializer for all your forms used by the application. So that's what a default initializer does. So here you're going to create a new library node for this called Day 3 Library and create a new top menu, a new resource file for that. So you're doing a preparation. You're wanting to create a default initializer, and then you need something for that default initializer to do to a form. So that's why you're creating a top menu. You're going to use this default initializer to load this top menu in each form as it's opened. So then you're going to modify the hide group MRS application to call a default initialization function for all the forms that are opened. You're going to call that initializer function init, and it's going to accept a form object passed to it as a parameter, and then use a form method to load a top menu into the form. And that's all it really has to do right now. Then you're going to enhance the user interface a bit more. You're going to apply a window style to hide the action panel. We don't need an action panel since we've loaded a top menu into our forms now with our default initialization function. So you're going to hide the action panel and make it look better. Exercise 4, you're going to create a start menu to launch your course applications. You don't have to do all of them because it's time consuming. You might not want to spend that much time, but at least create 2 groups, right? Create a day 1 group and a day 2 group so that you'll have something to look at, and then add at least a couple of child applications to that to launch. At least 1 child application in each group would be good, but you don't have to do all of them. That takes quite a bit of time. So here it's just walking you through creating a start menu, configuring the child parent program and the child container, and in addition you'll have to edit these child programs to specify these special ui.Interface methods so that they're child programs associated with the parent container. So you'll have some stuff to do for both ends, the parent container and the child container. And that's what we're doing here, talking about the parent container and the special methods it needs to indicate its special type and identify itself. You also need to load your start menu resource file. You'll be creating a start menu resource file as we saw. And then the last step is to configure the child programs and make sure they know their child programs and know who the parent is for the child. And if you have time, you can experiment with some of the other start menu styles. You saw the tree style today and the menu style today, so you might want to play with those, or you can play with the pop-up style as well.